Hey guys, welcome to the design session. In my previous video, first video, I essentially did a data modeling on LinkedIn, right? So a user can essentially create a post, people can like on the post, people can comment on the post. We essentially did model everything. Not only that, we also have done a very amazing project or a small lab which generates fake user post, likes, comments, and then we essentially also taught you how to query this data. Let's essentially build an aggregation pipeline now in DynamoDB. This is a design video where I'll be showing you the design, right? So let's get started. So this first part, right, we essentially did made, we did all these exercises. So I'll leave this video in the description. So what we want to do is basically now we have this table, right, LinkedIn. So a user can have post can have likes, can have comments, right? We made this materialized view. For example, for a given user, I can see the like, comments they have done. For a given post, I can see, for a given post, I can fetch all the likes, who are the user who did that likes. For a given post, I can also see all the comments, right? Who are the user who did the comment, what is the comment, right? Now, what is the use case, right? The use case here is I want to develop an aggregation pipeline on a post. So every single time any interaction happens on post, I want to essentially develop an aggregation pipeline in DynamoDB. So let's start designing this. So I'm gonna pick up a DynamoDB table. This is the table that we did in the last video, dev.linkedin. Okay. So this is the table which will, all the operations are gonna come to this table, right? Inserts, update, delete, all the interaction will go here. Now, what we will do is we will be essentially using, and we will do all this in the code as well, okay? But first, let's see the design. We will enable a DynamoDB streams here, right? So what we will do is this will help us to stream the data through DynamoDB. So all the event that comes into DynamoDB, insert, updates, all these will be coming in to Dynamo, and then we will be using Kinesis to store all these events. We'll set up auto scaling here, and we'll set up a retention policy for 1 day. Now what do I want to do is now I can use a Apache Flink to do a aggregation pipeline, or I want to build on Dynamo, right? So the whole goal is here, I want to do things on Dynamo. So what I will be doing here, I will be firing a Lambda. So the Kinesis will fire a Lambda, and then we can either use an SQS because we want to make it an async. So I'm gonna store all these requests in a queue, and then there will be an internal Lambda which will poll the queue at a leisurely pace, because remember, interaction on LinkedIn are pretty rapid. A lot of people are going to like, comment, share. So all this is going to come to the queue. We'll batch the data. This Lambda will take the data. Now what we will do is we will create a second DynamoDB table which this Lambda will insert this data to, and let's call this as an we can again call this as dev LinkedIn aggregate, right? So what this will do is basically anytime if you observe, anytime a post, or anytime on a post a like or a comment or any sort of interaction happens, right, I want to store that in the DynamoDB table. So what I will do here, I should have opened Excel at the start though, but I'll develop a view here. So if you observe my screen, yeah, all right, that's fine. So let me bring this here. So now I'll develop a second DynamoDB table. Here is my PK, here is my SK. Now here we'll have a post #1, whatever the post is, right? #1 will do a user. So post is made by whatever that data is coming, right? And now here, say we are doing likes, comments, right? So the first time, as soon as a post is created, we shall initialize these to 0. Now say a user came in and he commented. So what's going to happen, that event would flow through Kinesis. Lambda will capture that event. Then the Lambda will put the events into SQS, where we will batch the events together, and a second Lambda will fire. And these Lambdas, what they will do is they'll take the interaction that is done by whoever the user is on a particular post, and they will simply start incrementing the counter here, and same goes for a comment, right? They will start incrementing the counter here. So now this This table right here will give me all the metadata or the stats or the aggregation, right? So for a given post, how many likes have happened, how many comments have happened, right? How many people reacted, how many people shared, right? So all that events I'll be storing here. So now for a given post, I can easily fetch all the particular stats in one go, right? So what we are going to leverage is we are going to leverage DynamoDB streams. We will stream those events from DynamoDB in near real time. Will be after Kinesis will have a Lambda as a trigger. These Lambda are going to take the data and then simply put it on an SQS. And then from an SQS, we'll batch the data to a Lambda. This Lambda over here will have a library called PyNamoDB. We will batch the data, and for each item, we will simply start incrementing the counter in this Dynamo. So now what you built is now you have a stats, right? For each and every single post, you have a stats here, right? And if needed, you could also put on the same DynamoDB table. That's completely fine. But you do need, if you do need a stats table, you can also go for an aggregate. You can create a new table, right? So now, you can develop all sort of meta information in these tables. For example, for a post, you can see like, comments, right? Then for an example, another, you want to see, for example, a user, right? For a user, how many posts he has done, right? So if you want to see posts, the same approach, right? As soon as it's coming on the stream, it's firing Lambdas, SQS, Dynamo. So let's say this user, every time a user creates a post, this will increment 11, so oops, sorry, and 12, and then 13 posts, right? So this will always increment. So this will have a numbers, right? So yeah, that's how you would design this system, right? If you do have a use case where you want to aggregate data, so the way to do that is, let's have all your CRUD operation on Dynamo that's happening, stream those events to Kinesis. From Kinesis, we'll fire up a Lambda. From that, we'll take the data and put it on SQS. And from there, internal polling Lambda will poll the Lambda at a leisurely pace. We'll use a long polling there to save cost. We'll use a Lambda here with the PyNamoDB layers, which will take the data and update this table, which will give me all the stats about the user, right? User, post, and all the amazing information. So what you see is how you would design a aggregate pipeline, right? So now you're designing an aggregate pipeline. Some people will say, yeah, I'll load it into a Redshift, EMR, blah, blah, blah. Yeah, that's fine. But listen, man, there's nothing you cannot do in Dynamo. Let me just quickly share my screen. So really, it is super, super powerful. You can build all these complex pipeline that are powering your businesses, right? Likes, comments, views, all these aggregates, right? You could store that in the Dynamo, right? Now, if you want to build a BI dashboard, you want to see what are the trending posts, what are the total number of posts, all that. Now just dump QuickSight on this, and now you can easily build blazing fast BI dashboard. QuickSight now also announced you could embed these dashboards into your website. So now you could also, copy paste all your visualization in your website if you want, right? So all these you can easily build on AWS, right? So here, and again, this is just a design video. Next, I'll actually show you everything, infrastructure, code, every single thing. I'll build this entire pipeline on AWS, and I'll show you how we can, build all these amazing items, right? And these systems are actually, to be honest, being used in big companies for their aggregate pipelines, where they're storing, transactional data in Dynamo, then they stream these events out, then they create materialized view on that, right? So hopefully this made sense. And the next video is the project where we'll build all of this entire stack. Okay, we're gonna build it, so it's gonna be fun. So the next video is coding. Okay, so stay tuned for